Welcome to the beginning of trigonometry. Woo! Yeah, okay. Okay, maybe that's better. Anyway, all right, trigonometry. It is the study of triangles. More specifically, we deal a lot with right triangles. So when you're dealing with right triangles, one of the things you have to know about is how to label them. The opposite, hypotenuse, and adjacent. Those three things are very important for you to be able to do. Now, I made a slight error, and I do not know where I put the angle to reference here, so I'm sorry if it's the wrong one. You have little angle like there or there. I'm not really sure, so I forgot to bring a paper home to figure that out. So anyway, so everyone knows what the hypotenuse is, I hope. You have a right angle here. The hypotenuse is across from it, opposite it. Okay? Then we have two other angles that are acute. They're less than 90 degrees always. So here the angle is right here. We call that theta. Theta. Theta often represents an angle for us. And that angle right there represents this one. So depending on what angle you're talking about, the opposite and the adjacent switch places. So adjacent is always between the right angle and the angle. So that's always your adjacent. And opposite is always, well, opposite it. So I don't know where it is. I'm going to go with that's the angle. I'm sorry if it isn't. So we have that angle right there we're talking about. So we know this is the hypotenuse. Between the angle and the right angle is your adjacent. And the other one is the opposite. So say this one's the one. This would be your adjacent. Across from the right angle is your hypotenuse. And then the third one is the opposite. So between the angle here and the right angle, I got a little messy there, that is your adjacent. Okay, try the other two. Again, I'm really sorry. I don't really remember where I put the angles. So this would be hypotenuse. This would be adjacent and opposite. Okay, but if the angle I gave you was this one, that changes the opposite, not the hypotenuse. The opposite would now be this one, and the adjacent would now be this one. So that's what I mean by, sorry if I messed that up for you. So let's say that's the angle. If that's the angle, then this is always the hypotenuse. That won't change. But this is the adjacent, because that's the angle and that's the right angle, and this is the opposite. If it was a different angle, this might be seeming like I'm spending too much time on this, but I'm not. That would be like that. So depending on which one you had, there you go. So then we have the 6 trig ratio. So if you remember, hopefully you've done these before. These are the 6 trig ratios. You do need to know these. It's very important that you understand that this works with any right triangle. So if you have the sine of 30 degrees, the opposite side and the hypotenuse side are always going to be the same, in the same proportion there. And that's the whole thing from last year with geometry. Angles, triangles with the same angles are in proportion. So that's what this is all about. Sine is opposite of our hypotenuse. So the sine would be this one over this one. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So looking down here, if I want to find the sine of A, cosine of A, tangent of A, I'm looking at this angle. Sine of A, cosine of A, tangent of A. So sine of A, well, if we're dealing with A, this is the hypotenuse, this is the opposite, and this is the adjacent. So sine is opposite over hypotenuse. So opposite is 4, and hypotenuse is 5. Cosine is adjacent over hypotenuse. So that is 3 over 5. And tangent is opposite over adjacent. So it's 4 over 3. And I'm getting these numbers from right here. This is A, and that's O, that's H. 5, 3, and 4. So try to do sine of B, cosine of B, tangent of B. I'm going to use a different color. So this is your B. I'm using a different color because it never lets me erase. It's so annoying. So this is adjacent, and this is the opposite now. So can you do those? Okay, doing it this way, this being your B, okay, they change a little. So these are the answers to those. So to do this one, if I want to ask for the sine of O, cosine of O, tangent of O, you're like, but there's no numbers or anything. Well, what we have to do is we have to use the letters. So if we have a capital letter D for an angle, the side opposite is a lowercase d. Uppercase G, the side opposite is a lowercase g, and O and little o is a little hard to see. Look, it's dog and God, or just dog and dog, whatever you want to do. So that's what you have to understand. If it's an uppercase letter, it's an angle. If it's a lowercase letter, it's a side. And it's important you recognize that, and you take it from there. So like try to do sine of O, cosine of O, tangent of O, and the G's also. Take a second and figure that out. Right, so here's the answers to these. We have O. If we're dealing with O, this is the opposite. That's the adjacent. And if we're dealing with G, this is the opposite, and that's the adjacent. So you just have to get used to that. Okay, then we have the reciprocal ratios. And again, these you also have to know. So you have to just know them. Cosecant is abbreviated CSC. And that's 1 over the sine, or the reciprocal of sine. So if you take sine and you flip it, so this basically says flip sine, and you'll have cosecant. Secant is you flip cosine, and you'll get secant. And cotangent, you flip tangent. So the reciprocal means flip it, and that's what they are. So 1 over anything means we flip it. You can also represent them according to their opposite, adjacent, and hypotenuse. So as you can see, sine here is opposite over hypotenuse. If we flip it, it's hypotenuse over opposite, and it made cosecant. Pretty exciting. And the same with these two guys. So you may have to, find the 6 trig ratios according to t. In this case is where we want to do. So if we're looking here, this is t. First thing I always do is label my OA and H, and after that everything's pretty easy. So this is H, between the angle and the right angle. That's the angle, that's the right angle. That's your adjacent. And this is the opposite. So according to T, that is correct. Now I have to find all 6 trig ratios. So remember sine of T, I was going to write theta because it's the world I live in. Sine of T is opposite over hypotenuse. So I do need that H. So how do we find the third side of a right triangle? Well, Miss Barris, a squared plus b squared equals c squared? Yes, that's what you do. So it's 5 squared plus 12 squared equals the hypotenuse squared. Well, in this case, it's a. Right, little a. We don't know the hypotenuse, so we do this. So 25 plus 144. So then this is 169 equals a squared, square root. This is geometry here, so all we need is the positive, so it's 13. So now that I have this 13, I can do all the 6 trig ratios. Now I do these all at once. Okay, welcome to my world. Sorry. I do these all at once. Opposite over hypotenuse. You know what? You take a second and fill out the sine t, cosine t, tangent t. And then we'll go over the other 2. Okay, so you should have figured these 3 out. 5 over 13, 12 out of 13, 5 over 12. Now if I want to find cosecant, CSC, of t, that is just the flip of sine. So sine is 5 over 13, so this is going to be 13 over 5. If I want to find the secant, that's the flip of cosine, And if I want to find the cotangent, that's the flip of tangent. So that's it. That's generally how I do it, is I find the big three, and then I flip them to find the other three. All right, this one, I like to call this one the hidden right triangle, because they tell you the secant is 17 over 8. So we don't have a right triangle. But remember, if secant, you remember secant is hypotenuse over adjacent. So those are two sides of a right triangle. So if I say, okay, this is my theta here. Hypotenuse is always this one. So that's 17. And adjacent is between the angle here and the right angle. So this would be 8. So I want to find all 6 trig ratios, so I'm going to need this one also. So remember, this is the hypotenuse, this is the adjacent, this is the opposite. So I need the other side. So that's a Pythagorean, whatever. 8 squared plus, we don't know squared, but we know that's theta. We'll call it x. All right, and then we do the math. So find that third side and see if you can find all 6 trig ratios. Okay, you should have gotten the third side to be 15. And then when we figure this out, the sine of theta is opposite over hypotenuse. So the cosecant is 17 over 15. The key also is to remember that sine goes with cosecant. Sometimes people, a cosine goes with secant. They know that the s's and the c's go together. So in other words, sine starts with an s, cosecant starts with a c, so you got to remember that, they go together. I don't know, you got to figure out a way to remember that what's reciprocals of what. Cosine is adjacent over hypotenuse, so secant is that. Tangent is opposite over adjacent, so cotangent is that. All right, good luck. Have a good day.